All right, so in example 8, we're asked to find the number of arrangements of the letters in the word boo, okay? Boo with 3 O's. Okay, I made it up. It's not a real word, right? But I'm trying to illustrate. I'm just basically taking bold and changing one letter every time. Um, so we can actually list out all these arrangements, right? We could put the B first and then O, O, O. That's one arrangement. That's just what we started with. And then all we really need to do is move that B around. The O's are all indistinguishable, so I can arrange them in any order I want to. And I just end up with, it just turns out that all I really need to do is move the B around. And I'm going to get 4 arrangements. Okay. Now let's think about how we could figure that out using what we know about permutations. Okay. So again, if you just treat all those O's as being distinguishable, I could call this O1, O2, and O3, then there would be 4 factorial, right? 4 times 3 times 2 times 1 ways to arrange the 4 letters. But that is that permutation assumes that those O's are distinguishable, that we can tell the difference between B01, O2, O3 and B02, O1, O3, right? But really they're not. They're not distinguishable. And so in this count of the number of ways to arrange the letters, we're going to be overcounting by the number of ways to arrange those O's, okay? All right, so really what we need to do is divide out the duplicates by dividing by the number of ways to arrange 3 O's, okay? Assuming that they're distinguishable, right? So we're going to divide by 3 factorial, 3 times 2 times 1. So what it really comes down to is you're taking the permutation of 4 things taken 4 at a time and dividing it by the number of ways to arrange the 3 identical O's, right? Because it results in overcounting by that number of ways, which in this case is 6. So it's going to be 6 times too many ways. And so what you end up with is 4. Okay. So let's take a look at example 9 too at the same time while we're at it. So this is again very similar, only now we have the word toot. Toot. 4 letters again. Stay in 4 letters. So what we can do is just, first of all, just assume that all of those elements in that word, all of those letters are distinguishable. So we could have T1 and T2 and O1 and O2. So if they were 4 different letters, we would have 4 times 3 times 2 times 1 ways to arrange that. But then we have these indistinguishable T's and 2 indistinguishable O's. So how many ways are there to arrange the 2 indistinguishable O's and the 2 indistinguishable T's? Well, there are 2 factorial ways to arrange 2 things, right? I can write it 2 factorial, but it's 2 times 1, which is just 2. So sometimes I like to write 2 factorial just to help you recognize that that's coming from the number of ways to arrange the things, the 2 O's in this case. And then we're also going to have 2 factorial ways to arrange the T's using the multiplication principle that we have 2 factorial times 2 factorial ways to arrange the indistinguishable O's and T's for any given arrangement of the 4 letters. Okay, so what does that give us? Well, let's see. I can cancel a 2. I can cancel this and make that a 2. So it looks like we're going to get 6 ways. Okay. So we're just taking we have 4 letters. We have 2 O's and we have 2 T's, and those O's and T's are indistinguishable, so that's why we're dividing by 2 factorial times 2 factorial. All right, so I'll meet you in the next example.